Hello everyone. Today I'm gonna give you a short introduction into RybaFish tool, which can be extremely useful in HANA database analysis. We are not going to deep dive into tool configuration or detailed features overview, but I hope this video will be enough for you to understand what it is capable of, so you can make a conscious decision if you need to include it into your workflow. But before we start, let me show you something. Okay, this is an aircraft accident investigation report. And every report like this, somewhere in the middle, contains charts with interpretation of the flight recorder, also known as a black box. After decoding, such kind of graphs are built for the subsequent analysis and interpretation. There could be a lot of lines on such charts representing data from different sensors in different units of measure, but what is unique about them, they always have the same timeline. You can see it down there. Having stuff on the same timeline makes it easy to see correlation of different metrics, if there are any, of course, and the evolution of the situation. It might be confusing at first, but with some experience, it makes this representation the best way to understand the system behavior and the situation development. So if those guys use it for aircraft investigation, why don't we use the same approach for the database analysis? And HANA developers took care of it on HANA side. HANA already has such flight recorder or black box built in, collecting a lot of useful telemetry about HANA behavior. Unfortunately, there is no proper tool to decode this data and interpret it. And that's where RybaFish comes into play, because it was specifically designed to solve this task. Okay, this is how it looks like. In this case, we have top to bottom allocation limit, the amount of memory available. The green one is used memory, and the red one is CPU consumption. Those are three different KPIs in different units of measure, but with some experience, this will not be any problem for you. Scales are available in the application itself, and here on the legend. HANA contains a lot of KPIs built in. I call them standard KPIs. They're collected by the name server. And this information itself is already very useful, because you can see how the system is breathing, the dynamics of those KPIs, and so on. And as I mentioned, it's not just three of them, there are many more. And on top of that, RybaFish provides so-called custom KPIs. Those are extensions that can be additionally configured in the tool. We'll have a quick look on that later. There are three types of custom KPIs. The first one is regular. They look exactly like standard ones. There is a blog post on Subblocks describing step-by-step configuration of a regular custom KPI to monitor the size of the specific table. I will provide link in the description. The second type is my favorite, Gantt chart. If you have some process with start and end times, you can define a custom KPI with type Gantt, in this case based on the expensive statement trace. So we see what expensive statements were executed during the defined period. And in this case, we see that increased memory consumption most likely was related to this statement execution. Not for sure, but it is very likely. Same here. And this CPU spike likely is a result of corresponding statement execution. And there is one more, multi-line. It means we can enable one KPI and see several lines on the screen. In this case, it is memory consumption drilled down. I mean heap areas composing total memory consumption. And we can see that most of the memory increase is a result of this line, which, if we check here, relates to the system memory component. It might be hard to see on the static picture, but in the application, you can click on it and make sure you pick the right one. Once again, all the custom KPIs are just part of the tool configuration, so you can go even further and create a very detailed memory consumption drill down to the level of allocators. So you are only limited by your imagination and, of course, knowledge of HANA monitoring views. In addition to charts, the tool has quite powerful SQL Console. It has all the usual things like syntax highlighting, error highlighting. It saves the layout of open tabs, which is my favorite thing. Just like in Notepad++, you can close the tool, open it the next day, and all the tabs gonna be on the same place. You don't even need to save anything. There is a small SQL browser to organize your scripts and favorite SQLs, and on top of that, automatic refresh, sound alerts, etc., etc. So it's quite mature and advanced. Let's see how it looks like. The tool delivered as a portable build. You can unpack it wherever you want. It's about 50 megabytes. No Eclipse or Java or ABAP required. Just start it. We need to connect it to the database. I have a pre-configured connection to my test system. Let's connect to the systemdb first. Let's enable something and I explain what do we see. On top, there is a main charts area and its controls, timescale. You can also adjust it by the mouse, control and mouse wheel to zoom in or zoom out. And there is period from and to. Let's start 5 a.m. Enter key applies the change. Now we see the data starts from 5 a.m. Bottom left, there is a list of hosts and services. In case of scale out, we would see several hosts. As we have just one, we see the same host and its services. As we connect it to the systemdb, we also see different tenants. I have just one. On the right, there is a list of corresponding KPIs. When the host is selected, there are several host metrics. On the service level, there are much more KPIs, about 50 of standard ones. And for host level, I think it's just about 15. Let's make sure this CPU consumed on the index server. Enable the service CPU. Nothing changed. Now disable the host level CPU. And we see most of the activity was indeed on the index server level. So let's switch to the index server instead of systemdb because there is much more information inside the tenant compared to the systemdb. Custom KPIs mostly based on service-specific data available only inside the tenant. Yeah, on the bottom there will be hotkeys. I press, change the port number to the service. Let's enable memory consumption and memory allocation limit, so we see how much memory left. On the top left there is a legend, which might be extremely useful, because if you want to share a screen, it will have the legend with scales and it will be possible to understand the values. Here for the memory, max value, last value, because a week later nobody will remember this. By the way, I have everything in huge fonts because I set the screen scaling for the sake of this demo. So everybody will be able to see letters and numbers, but normally my system looks like this. Much more space. But everybody has different screen resolution, so I hope this is fine. Let's hide the legend as it rather distracts and have a look what is going on here. I normally put a limit on the period to speed up refresh. Custom KPIs can have a lot of data. So the most interesting part for us is to understand what is going on here. Who is responsible for the activity we see on the screen. And in most cases, this is SQL statements executed, and the expensive statement custom KPI might help here. Let's enable it. And immediately we see that CPU and memory consumption perfectly aligned with statements executed. For instance, this statement is aligned with CPU consumption. In the middle, there is additional CPU spike, obviously a result of this statement. You can click on those bars, so you see some details. And this is the user responsible, DB user system, and application user data load. And hint shows statement itself and some details. We'll have a look a bit later. Seems this CPU spike doesn't have any statement. And that's true. It was internal database activity. Trust me, I checked. Okay, the main statement executed by the RIB the system user. It's just a test procedure generating data. And the best thing is the whole custom KPI definition is just a tool configuration that can be changed on the fly. So let's see how it works. Here is the KPI group Gantt. Let's open the folder SQL Gantt folder corresponding to the group and open the KPI definition file. The whole logic of this Gantt chart is defined in this file. There is some metadata like title, color, and so on the top, and the main part is the SQL statement down below. There is a reference page on the RybaFish site on this, and I think I will record a screencast step-by-step session on this topic later, but now let's do a quick change. So the grouping of the Gantt charts is performed based on this entity field. In this case, it is a combination of DB user and application user. Let's change it to statement hash, just to give you an idea how it works. Save. Reload custom KPI definition. And now we need to refresh data. And now the same statements arranged a little bit differently. We see the SQL has this statement hash. We also see there were 4 different statements in this time span. Let me zoom out. The CPU consumption generated by this statement hash 3 times, even 4. There was quick one. And the last one seems similar, but it has a different statement hash. CPU consumption is similar, but the memory pattern is different. If we have a closer look to this quick event, it looks unusual. Same statement hash was running, but in the end we see an overlap with some other statement. It is very likely this memory spike is related to it, very close to the limit, and it is very likely we had an out of memory here. And that means those two very likely terminated with an error. If we have a closer look on this statement hash, we see it was executed again, and again with CPU and memory spike to allocation limit, and again very likely it failed with allocation error. But we cannot see it anywhere in details, so let's add it to the KPI definition. And to the details, let's add an error message. This column is available in the expensive statement trace, so we don't need to do any extra steps. Reload the custom KPIs definition and reload the data. And we see now that it was an allocation error. This one failed, and this one also failed. So custom KPI definition is just a configuration of the tool, and we did not even need to restart it to see the difference. If we need to investigate details of this event, we can copy the statement hash like this. That's the hash. We can also copy the details if we need the error message. We can save it, investigate further, send an email, and so on. Let's revert the changes. Reload, refresh. And now have a look at this situation from the other angle. We can check the memory drill down to see the component responsible for the memory growth. Okay, at this, we see several lines appeared. Each one shows memory consumption by the particular memory component. Let's see some details. This cyan one relates to column store tables. The status bar shows detailed information. It behaved interestingly. You can jump to the next one by Alt and up and down key. The main memory growth was in the system memory component. This also available in the legend system before it was column store. And now let's have a look on those terminations with memory details. We see column store decreased, and we can cross-check by looking at column unloads. Yep, column unload spike, the pink line, and that proves there was a memory shortage in the system. In case we want to go absolutely crazy, we can go down to the allocators level. Let's disable the components KPI. Yeah, there are several unload spikes during this period. And now enable the allocators drill down. This will take some time because that's a lot of data for each allocator. And we have this real impressive modern art masterpiece. Not very informative. But this KPI has online settings in this variables column. This one allows to change stacked flag, make it false, and we need to reload the data. Because this looks nice, but not very clear which allocators actually consumed memory. Okay, and now it's perfectly clear that in each event there are several top growing allocators. Let's zoom in. It's hard to see on the scale, but let's change the memory scale 5 times. On the top we see unified table container. Now you can go to SAP notes and check what this one is responsible for. It was actually big even after the statement execution. And the main growth was in this violet allocator, persistence, blah blah data page. Again, you can go check the SAP notes and check if this is okay for your system or not. In parallel, log manager. So only using the mouse, we can go deep to the allocators level and see the detailed memory consumption drill down, of course, if we are curious enough to do so. Again, there is no magic here. The definition of the KPI is just a file again, multi-line, heap allocators, statement itself, and the metadata defining how this data should look on the chart. There is a reference on this on the site. You can jump there from help, custom KPIs reference, Gantt definition, multi-line, and variables that allow to do some online changes in KPI definition without file adjustments. Okay, let's get rid of this noise and have something reasonable here. Reset memory scale. That was charts overview. In addition to charts, there is a quite powerful SQL console. So there is a statement, hit F8 or F9 to execute. Let's have another one. And now to run it, you can select it and hit F8. Or a more convenient way, if you see it doesn't work, put a semicolon, and now we can execute them separately based on the cursor position. Here this one, here that one. Quite convenient. Main operations are available in the toolbar. The last one is jump to the console reference page. It's quite detailed. Let me show you a couple of other features. Let's see, auto refresh. 10 seconds. And you can see the indicator of this console is light green, and the hint shows the next execution countdown. So it is 48 seconds. 58 now. There is a SQL browser where you can organize your scripts and favorite SQLs, so you can access them from the RybaFish without copy pasting. Let's check this one. New console. Execute. And we have some result. All this stuff just organized on the disk. Scripts folder. This is mine collection. Tool itself comes with just a couple of examples. And we prepared something. This is it in the file. This depends on your preferences, of course, but I personally switched to RybaFish SQL browser. Let's check another one. I have a load generator. I just executed it. It will generate some CPU consumption. Let's make it refresh itself. It will go automatically. It did, but because we have the end of the period defined, of course we didn't see. Make it open, and now we see a statement right here. Let me run it again. While it is running, the indicator is bright green, and it shows for how long the statement runs already, which is very useful. When finished, it is gray again. Make it run a bit longer and disable auto refresh. So we see it is running. This one is scheduled. This is very useful in some cases. I plan to have a video on that auto refresh topic. You can switch tabs by clicking on the indicators. And I almost forgot to show you my favorite thing about the consoles. Okay, we have some stuff going on here. Let's open another one. Something, I don't know. Another one. So I was doing something here, test, and suddenly I decided to stop for today and go home. And I just close it. The next day, run it again. And I have the same stuff open. The whole environment is the same. I have the same things, same place. I didn't even need to save anything. I find this extremely useful and convenient because you have like complete environment consistent, which is quite nice. So I think that's it. There are a lot of things to talk about, but I hope you now have an idea of what is RybaFish is capable of. So leave your comments and questions below and see you in the upcoming videos.